currently all the cells are 100% charged about 4.2 volts. And the idea that we're going to do is we're going to take off from our, I'll explain the basic flow of control. We're going to take off from our home position and then map the arena. And from there, we can get the safe spots and come down and land on each of them and hopefully go back to the home position also if the odometry lasts. So how we're getting this odometry is we use our Stereolabs Z2i camera over there. It's a depth camera. We use that for something called visual SLAM. It's basically visual simultaneous localization and mapping. You'll be able to map our environment while also moving around it. So that is how we are getting all of the positions, and that's how we can run a clustering algorithm on whatever depth map that we get to get all of our safety spots. And
So entire thing you are going to plan autonomously from the go one from the go?
Yes, if everything goes well, we will be able to pull this off completely autonomously. Okay. And I would like to also say that when we are doing our own test runs in our own arena, in our institute, we were able to get multiple successful runs all the way up to the third safe spot.
Okay, okay. In the periphery also, you'll be able to identify with the yellow marking. That's also part of this.
That'll be done. And we use that to actually localize, more or less.
And two more tasks are there just to demonstrate the safety. If link is there, link is down, you may have to come down. Probably you would have seen that. Safety and then battery safe also, it has to vertically come down. So that also you can demonstrate after this.
Yes, understood.
Okay, okay. Yes. So if you are ready, you tell. Otherwise, some questions you can take means okay. Otherwise, if he is ready, go ahead with that. So go ahead with it. Yeah. And you announce the activities. Somebody, whatever you are going to do, you please announce. Okay. Go ahead, please. All the best.
Thank you.
You can also say what you are going to display. Will you be able to display the safe zone, all that? The base computer, are you showing something? You just. No, the base computer, are you going to show something? What is happening? Yeah, he's going to, maybe he will connect this camera live. Okay. Okay.
You'll shoot your laptop.
Okay, okay, for any safety purpose you can use. Okay, fine, fine. Yeah.
Excuse me, sir. So here, Sudhin Raj from our team will explain what all the windows and all the terminals here. I'll pass on the mic.
Yeah,
So,
if
this is the odometry position of the.
if you are ready with the demonstration, you can go ahead. Because if there is a constraint, you go ahead with that. Okay, you decide. Much better. They have made an effort. Good effort. Correct. Correct. They made good effort. Correct. Professionally, they admire. Easy. Okay.
Excuse me. I'd like to point out there's been a small issue in our. Can you hear me? Hello.
Yeah, go ahead.
Okay, so there's been a small issue in our remote controller, so we're slightly going to recalibrate it. It's going to take not more than a couple of minutes. So I thank you for your patience. Actually, no, don't do that yet. There's no terminal to explain all that. Okay, we will be starting the mission in a couple of seconds now.
The drone has taken off. The present height is 2 meters. It's stabilizing at the takeoff height.
Srinivas, can you explain what has happened?
Yeah. Our line detection and corner detection failed, so we are retrying the mission. Yeah.
Okay. What has failed?
The line detection and the corner detection has failed, sir. The yellow line detection and the corner detection.
Okay.
Yes. Yeah.
Yellow line detection.
Okay, we are ready to fly one more time.
Okay.
The drone has taken off. It detected the line.
Okay, it has identified safe spot. Did it identify?
No, sir. Still, we didn't scan the area.
Okay, okay, okay.
Sir, so we are about moving in the process of line detection. So what is happening is that we have kept the distance threshold for the line. So apparently the distance threshold is quite high for it. So the distance is being detected quite before, and like the drone has thinking that it has reached the line. So we will just tune the code once again and we'll run it again.
Okay.
Yeah.
So currently what is happening is our yellow line detection code, the HSV ranges, the rocks are coming within that range. So the minute the drone takes off, it's thinking it has reached the yellow line, which is an issue we're facing right now. So we're trying to fix the HSV range.
to change orientation?
Rocks are getting detected as yellow, it looks, so that's what it is. That's why he's trying to lift and look at that rock, and now it is not detecting as a.
We are running the code.
The drone has taken off. It detected the yellow line. It's going for corner detection. Land.
Okay, okay, safety landing has happened. Did it land safe? Okay. Manually landed.
So the drone detected the yellow line, move forward. Then it was moving along the line to check the arena and detect the corner. But corner detection failed. It was not able to detect the corner, so it exceeded the arena limits.
Hello. So we'd like to air one small suspicion that we might have had. Could have been pure accidents, but over here, the blue color net might have been on top of the yellow line, which might have stopped the algorithm. So I feel like maybe that could have been a reason why the corner detection over here failed. The camera might also have a part to play in this, so maybe we can shift it slightly backwards and keep the net off the yellow line. Might actually work better.
Okay, okay, we can try. But the wind was moving slightly this side. It was moving actually slightly during that time. Okay, somebody we can ask them. People to, not an issue. The illumination you want lighting to lighting. Okay, good. If you go. So that if you want, yeah, some. Yeah, take care. Yeah.
Srinivasan, your cameras, you have a set of cameras even below? You are having only one camera. How it will detect that yellow line?
The camera has a pretty wide field of view plus left and right cameras, so there's a threshold distance that we use.
Oh, you have
So
left and right also, is it?
Yes, it's a stereo camera. It has two separate lenses, like
No,
two
no, no.
separate cameras on each side. No, in the same camera, basically. It's a stereo camera.
No, I understood that, but your camera was facing in this direction.
Yes.
How it can detect that yellow line?
Which one? This one? This one? It can actually, like if it's sufficiently far away, it'll be able to find it. We've actually tuned for that one. It is, as long as it can keep a safe distance from the yellow line, which is what we have actually coded it to do, it'll be able to detect everything in its range. There'll be nothing missing. Okay, we will be reading the code in some time. I think we might have figured out the issue. You have to see.
We are running the code again. Takeoff initiated. Line as detector. Approaching the corner. Land, land.
No, sir.
So we have done this before. It works properly, like as long as you maintain a proper distance. The thing with the drone is it's very unstable in the yaw. So if we do that, it actually spins out of control very much. So we don't want to do as much yawing as possible. So we just keep it completely free. You can try that if you want. You can face this way.
Yeah, we'll change it to versus. Sir, I get that. No, sir, we solved this.
So we will call the next team. They will take some more time and come back. Okay. This team will be back after that. Next team, Jart. Huh? Okay, okay. So next team is ready, no? You are ready now. So next team will be Jart from IIIT Dharwad, correct? Okay. You can pick the position and the heading. You can just pick one thing. Yeah. Let us see what is that. And the heading also. Position is 4. Heading is east. Okay. Okay. I think you know the competition requirements, correct? So from the home position, you have to hover around. You have to scan for the safe spots up to about 2.5 meter, and you have to land in 3 safe spots and go back to the home position. Okay. The yellow line is marked for the periphery. And if you need any illumination requirement, you can tell. Okay, any issues are there also, you can just put, or any heading requirement. Also, you can tell. Okay, and you have the 3 attempts nominally. Okay, and you can do fully autonomous or semi-autonomous, where you can identify the safe spot and try to go manually, or fully manually in case you have an issue. And take care if any safety requirement is there, you take care manually. Okay, that's the requirement.
Which side is east?
This is north. This is north, south, west, east. That is east. If you find any difficulty, you can change. You tell us. No issue. You try. Yeah. Okay. Okay. You will plan with fully autonomous.
Yeah, fully autonomous.
Okay. Okay. That's good.
Yes, sir. Just after
Okay,
calibration,
you
I'll
can-
just arm it, take it up for a, just take it up, put it down, then fully autonomous. Yeah.
Okay.
Yes, sir. It's fully autonomous. We just need to make sure the sensors are working. That's all.
Okay. Your name? Who is?
Yes, sir. Fully autonomous. Okay. So our algorithm is a sweeping scan algorithm. We have a tilted camera, a depth camera, which looks farther as well as down. So we have implemented depth anything, which is a highly classified image to depth analysis. So using that, we get the depth analysis of the image, the ground below. In fact, anything. So after that, we use an edge filter called Sobel filter. So through which the edges of the rocks, even the safe spot, if it's perfectly flat, we get to know if it's flat or not, perfectly. So we align that with another recognition model, which recognizes those flat patches of lands, and then we have a control algorithm which centers the heading of the drone towards the safe spot, and then approaches it. Yes, sir. So after we go to the safe spot, we have a downward facing LiDAR. It detects the angle, precise angle of it, the elevation of it related to the drone, as well as the area of the patches of the land. It can determine that. So we have currently kept it as 5 cross 5. 5 cross 5, feet, sir. Yes, sir, 5 cross 5. And it can work with 4 cross 4 as well. After we land, it takes off again. And then in the clockwise rotation, we have kept it as such. It rotates to find something, another safe spot. And once the safe spot is identified, it directs its heading towards it, goes there and lands, again gets up, does that for how many number of specified spots are there. And then after each and every spot is achieved, we go to the home position again.
Okay, your name is Suresh.
Saurav.
Saurav, okay.
Yes, sir. Our battery can support with the whole rotation, one rotation test for about 9.5 minutes. Yes, sir.
Okay, you can start setting it up, and
Yes,
you can announce the operations. This is the home position. Home position is changed because of your
All right, sir.
fourth
Okay.
point.
Okay, sir.
You told some calibration you will do. What calibration you are going to do?
So we are going to do gyro and axle calibration.
Okay, fine.
Yes,
Okay.
sir.
Okay, right.
All right, sir.
Okay. All the best. Keep
All
it with you. Announce
All
the
right, sir.
activities. Okay.
So we will be starting the manual calibration testing shortly. Afterwards, we'll continue with the autonomous mode. So the manual calibration testing has been initialized right now. It is coming out pretty stable. We'll be landing it now. So we have initialized the autonomous sequence right now. It will be starting shortly. It's initializing the sensors and seeing whether everything is in pitch condition so that it can take off safely. Okay, so it has been armed. It has takeoff. It has took off to an altitude of 3 meters. Now it will start scanning. It has found the safe spot. It is moving towards it. As you can see, it is hovering right now. Right now, it will be checking whether the safe landing spot is at a slope or a normal safe landing spot. It has landed there safely. It will take off shortly. So right now, our drone flew over it, calculated the angle, and found that it was a slope. So it is initiating a different kind of landing sequence apart from the classic one. So now it will take off from the spot and scan for other safe spots.
There is no obstruction, no? It can move up, isn't it? Okay, good.
It has taken off. It will start scanning again. Yeah, scanning initiated. It is searching for a safe spot right now.
Identify this as safe spot? Okay. Okay. No, it identified home as a safe spot, or?
Yes, sir.
Okay, okay, okay.
They put it as one issue. Yes, yes, it does. That's why. That's why. Okay.
So as you see, the drone tried to land on the home position. What initially happened was it looked for a flat land, flat surface, and it identified the home position as a flat surface. So it tried to lock into that position and it moved toward that position. But unfortunately, since there is no texture on the home spot, it couldn't lock onto the position and it drifted a bit. And one more thing, we only tried to search for one safe spot initially. Now we will be trying to attempt for all the three safe spots. Thank you.
So your battery is in charged condition? Already you have spent some time. Okay.
Yes, sir. We have extra batteries as well. We're just checking the status of the propellers. So, just a second. So we have, if just a small test. We've initialized the code. Now the sensors will be initialized. So all the sensors get activated during this process, and we start reading the data from the sensors.
The drone has taken off now. Now it starts scanning. Yeah, it's currently looking for a yellow spot so that it's aligned along it. It has found a corner, so now it will start scanning for the safe spots right now. It is gradually rotating. It will find the safe spot, identify it, and gradually move towards it. It is slowly moving towards the safe spot. It is slowly scanning it. Yeah, it has locked onto the safe spot and is moving towards it. It is hovering over it and it is finding the angle of the safe spot. It has landed there successfully. It will be taking off shortly. It has armed. It will take off now. It has taken off now.
So we have to change a few configurations so that it detects this better. Can we have some more time, please?
Yeah, what is the now observation? It is able to find the second spot. It has rotated once, no?
Yes, sir.
Okay. Yeah, you can bring it down and then. Okay, fine. Now, you need some change, is it? Okay, yes, to adjust it.
Enough samples, but he's not converging. So there is no way out of that. So he's getting stuck.
Okay, fine.
Some time limit or something you have to put.
Okay. They will be able to adjust that threshold. Okay.
Yes, sir. Excuse me, sir. So what we had trained our models on was a bit more rocky terrain, more rocky. So if possible, if we can surround the safe spots with more rocks, it would be more beneficial.
We may move some sand in the boundaries. It will become, terrain will be different.
We were saying that we need more rocks around the borders, around the safe spots.
No, if you make slightly at the corners, contrast. The
Contrast
if
is
you remove
required,
some sand, it looks some boundary will be visible in this safe spot.
No. It's not image. We need rocks around the borders. So the model detects the rocks. So it declassifies some places. So it has seen it as a bit more skewed. So it has decided it's not a safe spot, and its confidence value is low. So we're changing that. If that doesn't work, we would kindly request us to change something.
Or if we can do a semi-autonomous, you can feed the coordinates and make it move. There is one more choice, is to go as semi-autonomous.
Okay.
You can feed the safe spots. You can go
All right.
Is it possible?
Change the contrast I want to change.
No, he wants to put this one, rocks, additional rocks.
No, what you change is the confidence interval, you will bring it down, right?
Yeah.
So bring it down and try once. If not, then we will see what happens. So Arena cannot be changed. So
not classifying them as a safe spot because of the lower confidence threshold. Huh. Yeah, we are able to. It is look. Yes, sir.
Blue boundary is kept on coming for slant only. You are not able to come forward and find another blue boundary.
Yes, sir.
That is the problem.
You are not.
Yes, sir. So we need some kind of bordering so that it detects.
No, not that.
Yes, sir. Yeah.
You are
We'll change
hovering
some
at the
parameters.
you are hovering at the same place.
Okay, you need
Whether
some time.
If you movement any movement if you do, then you can get that your spot blue spot you will get actually.
For
That
the slope,
that
how
whether
it's
you are
indicated for the slope, the first.
Yes, sir.
The first.
So it is flat and there is some kind of bordering around this thing such that it knows it.
No, that's what. If we remove some sand out that, that's
No,
also.
no, sir. It's
That is not the reason. Can you show other side what it is showing?
Yeah.
Just
Other video.
you are not able to cover
Sir,
full
sir,
terrain.
what is happening now? This is one thing what I'm suspecting.
He is hovering here that he is not able to cover the full area now.
But he is
That's why that space is you are not getting that.
Sir,
Because the stones are not good enough, it's not taking that as a flat surface.
sir, actually, sir, that because of elevation, you are not able to identify that as a.
That is actually spot. But then the moment
Okay, okay. Okay. Okay, you can reduce the confidence level, immediately it can detect. That's fine. Okay, you can go ahead.
is good. Then later is reducing the confidence
15
interval.
minutes.
15 minutes, huh? Okay, the other team is ready. That which team? The say fifth team or new team? Seventh team.
Second team is coming back.
Okay, then you do one thing. You just come back with whatever the tuning.
Oh, let's done.
Yeah, yeah.
Changing constant of the threshold. Yeah. A couple of numbers. Like. Yes, sir. Yes, sir. Most definitely. Most definitely. Yes, sir.
This team, next team will come now, seventh team. They had momentarily identified. When they started moving, it went off. So that confidence factor they want to reduce. So convergence they want to reduce. So they sir, momentarily this seat identified. That was coming every time. This seat identified momentarily, and then it went off again. So they are feeling that it is not confident. Confidence factor is waiting for more time. So they are trying to reduce. Next team is Team Titans. Ready? You are ready. You can come and pick up your point, place. Your name?
I'm the team lead, Sanjot.
Sanjot, okay. Sanjot, you can pick up your position and the heading. If it is same. So the point is 3. 3 and heading, you will just get this. North. Is okay for? North is this direction. 3 is somewhere. 3 is where? 3 is also here, this side only, no? Spot 4 last time. Nearby only. Is it okay? Any position is okay for you? Yeah, you will see that. You can, it's choice. So, and you know the requirement, isn't it? So, from the home position, you have to see, go above. Okay. From there, 2.5 meter minimum, you have to scan and identify 3 safe spots and land and go back to the home position. That's the requirement. And anyway, you know the periphery is marked with yellow. If you need any illumination condition also, you can tell, okay? And there are 3 choices for 3 attempts are there. And you can also do fully autonomous. And in case you have problem, you can intervene manually. At what stage you can tell. Semi-autonomous means let it identify a safe spot. And you can manually do that. And or totally manual means, okay, accordingly you have to plan, okay?
So we will be taking a manual flight intentionally just to check if the system is like the sensor are giving proper data. So sir, we will be starting with the checklist. So we are performing a checklist that every system is okay. Then we will take a manual flight just to check that every... No sir, nothing will be trying, just one takeoff with the RC. So that every connection is everything okay and we can go for the autonomous. So that will give us more clarity. In that we will check the sensor data and if illumination is required, then we will be asking. Then my team will give me okay, we will going complete autonomous. Yes sir, sure. Sir, that's the position? No. Yes sir. Okay, so can I confirm with my team? Sure sir, give me a minute. Excuse me, sir. Sir, heading we have to change it towards your side, like facing to judges. Home position is okay. Position is okay. Yes. Sir, towards judges. Sir, what we did, actually I will explain it. So as you can see in the screen, we have presented a PPT. So how we will be going forward, I have been explaining that. Yes, sir, I will. Because our search pattern is according to the spiral. Yes, sir. So there is a basic block diagram. So I will give you just a normal brief. So we are using Intel RealSense camera. So till then the setup is going on. Just I will cover in the brief time. Yes, sir. So we are using 2 major sensors, the camera-based sensors, which are Intel RealSense depth camera. It has stereo camera, RGB, and a depth camera, which uses active IR to take the distance, the depth sensor or the depth data from the frame. And also we have an edge flow sensor, which is an optical tracking sensor. Because as we know, we are in a GPS denied environment. And in that, there will be position where the drone will drift. So to calculate the drift, that how much is drifting, so optical sensor give us the velocity in V and, velocity X and velocity Y, so that the PID in the FC can calculate it, so it can correct itself and maintain a same spot. Then also in the, and also in the sensor, we have range finder. It will give the height from where the drone ANAV is flying. Then this depth data and every tracking data is gone to a NVIDIA Orin Nano, which is mounted on a carrier board. This Orin Nano calculates everything, tracks, processes, and give us the data to FC, the flight controller. The flight controller we are using is the Cube Orange flight controller, Cube Orange Plus flight controller, which has 3 IMUs, 2 barometers, 1 magnetometer. We are not using the inbuilt barometer and magnetometer because there is very much EMF noise nearby the FC. So we have mounted an external magnetometer, a compass, to have the proper heading. It's mounted on a stand over the ANAV. So when we will be seeing, there will be a stand and there is magnetometer is connected. Now this FC takes the data from Orin and calculates according to the power which has to be given into the motor. And accordingly that power is given to the motor. We have 4 motor propulsion system. Then everything is tracked by the base station, which will be having different parameters. I will explain in further slides. And then this everything is powered by lithium ion cell battery packs, which has been configured as 4S2P, giving us 9,000 milliampere hour, which gives us approximately flight time of 16 minutes. Yes. Then coming to the navigation algorithm, as sir suggested, why we are not using that heading, because we are going in a spiral search pattern. So in this spiral search pattern, we require the complete grid in a square pattern. So this is a 12 meter by 12 meter search pattern. But we know that our arena is smaller than 12 meter by 12 meter. So the ANAV will take off, it will go in the direction for 12 meters, and then as soon as the yellow line is detected, it will stop and it will change its direction. So that square spiral pattern will happen. And accordingly in every direction it will work. Then we are using a FLVIS based coordinate system. As we know that we have to come back to home, we should have the coordinates of the safe spot. So we are using a FLVIS. This is actually an open source library developed by Hong Kong Polytechnic University. And then we have actually tweaked it according to our requirement. And then we are using it for our drone. So our coordinate system is working on that library. The detection algorithm. So this is actually our own developed indigenous detection algorithm. Our own teammates has been developed this algorithm. We have named it depth-based similarity matching algorithm. What we do, as I told, we have a depth camera. The depth camera gives us depth information in mm. So if a drone is flying at a height, let's say 3 meters, so the below in the ground, as we can see the white spots can be of the 6 meter. So what we did, we converted that depth data, the 0 to 6 meter data into grayscale reference scale to visualize it easily. Then as we know, the 0 is 0 meter and 6 is 255. And accordingly, every shade of grayscale is a specific distance data. It's not an RGB converted grayscale, it's a depth converted into grayscale representation. So as you can see in the design, one second. Yes, sir. So what we did, we compressed the 6 meter into the 225, and we are flying at a 3 meter of height. So we are getting till 125, the value, the maximum value. So we are getting very much variation, like we are taking it. So as you can see on the screen, we have the darker shades which is near to the drone and the lighter shades which are far away from the drone. So no lighting condition will affect it because it's complete on the depth sensor data, which is on IR. So no RGB can, like it can work in dark. No RGB sensor is required. So let's say that we are taking a top view. We have in a Martian space and every shade represents a difference in height. So what we did, we converted into a grayscale image. Now grayscale, we can easily process it for a further investigation. Now at each pixel data, we have some value. Let's say it's 128 Then what we did, we applied a 3x3 mask where variation can be colored difference. Where variation is very small, it's green. Variation is large, that is red. Then accordingly, we can create a pattern where the same level things can have a green color and then the red. Accordingly, we are giving us pattern. Then we are finding out the clusters and then we are aligning with the largest cluster. So hence we are finding the safe spot in this complete depth-based scenario. Also, we are finding the direction of the slope where it will be of the slope which is under the ANAV. So arrow will be indicating the downward direction of the slope. And also we will give the value, approximate value of that slope. So we'll be calculating that. Yes, sir. Yes, sir. So, sir, what we want to mention, like when we are giving the coordinates of the safe spot, we should know the origin of the arena and the safe spot's home point start. Okay. So we need to put the values in our system that where the home point is starting. So give the coordinate system, but yes, if we not do that, the 0, 0 will be assumed where it is starting. So every point would be according to that 0. So that will be okay. Okay, sir, not an issue. We can work with that. 0, 0 will be our home point, and otherwise every safe point will be calculated from the point which has taken off. Sure, sir, we have not an issue. Okay, so accordingly we will be giving. This is a small screenshot of the HUD, what you will be seen on the screen. We have the artificial horizon, roll pitch yaw, the other data like rangefinder data, the optical flow sensor data and everything. Then in that we will be having the navigation map and also the depth, what I have told, the detection algorithm, that red dot and green dot. So that will be presented there. Now we perform a little checklist. So the only reason of checklist is to verify everything. Yes, sir. Can we move? We do. Yes, sir. They are just verifying it. Everything is working. So just to verify everything, we will be having a manual flight as I told earlier, and then we will be moving for the autonomous. Then we are completely ready for the autonomous. So yes, sir. We will just have a manual flight, a RC flight, just take off, land. It will verify everything. Integrity of the system, yes, sir. And then we will be giving go to our programmer. He will give one click and everything will be autonomous further. In autonomous, it will take off. Sir, so I will explain in brief. It will take off to a 3 meter of height and it will start scanning. If in that scanning process he gets a zone, a safe zone, he will land first, he will center to that, land it, and then again take off and it will continue the search path. And accordingly it will have 3 zones, and once 3 zones are completed, it will come back to home. This. And also we will be giving demo for the fail-safes. We have an RC fail-safe and a battery fail-safe. In RC fail-safe, we will start similarly, but in flight we will turn off our RC. So it will come back to 0, 0 and it will land on the home position. In battery, similarly, if battery is low, but we can't trigger that battery low, so we will giving an external trigger, like a threshold trigger, and once it detected, it will accordingly perform. Yes, sir. One person will be always on RC. He will not move any joystick, but he will for emergency purposes. If in any case, like we know, if the drone crosses the yellow border, we are also having 2 people would be inside to warn him. So he will take a manual intervention. That would be our manual intervention. We will inform you that, and then accordingly. Yes, sir. That would be completely safety purpose, because when we practice it, we don't have this net. So that was our intention behind it. Sure, sir. I will just join my team and I will give you 4. Thank you, sir.
You have one more mic maybe there. Careful, careful.
Good afternoon, everyone. I'm Neha Prakash Tonge from Team Titans, and I will be explaining the further operations for our ANAV. Now, our pilot and co-pilot is going to perform a pre-checklist and a manual flight to ensure that all the hardware are working in its full efficiency. Manual flight has started. It's going to take off. Our software integrator is going to start the autonomous task through a command.
Is the feedback okay from manual run? It was all right?
Yes, sir.
Okay.
Our system has been now booting up. As you can see on the screen, the various data from the ANAV has been. This is just to screen record the HUD for our purposes. So,
The task has initiated. Our aerial vehicle is in the takeoff mode, slowly increasing its altitude up to 3 meters of height. Moving the camera from upside down to maintain the odometry. Once the camera is all set, the aerial vehicle is going into a next mode, which is a navigation mode, a spiral-based navigation. Moving forward in search of safe spot until it sees the visual fencing, which is a yellow border. can observe, our aerial vehicle is going up and down. Because it's trying to maintain its altitude at the 3 meters of height from the irregularities present in the Martian terrain. And here, our aerial vehicle has detected its first landing spot, trying to align itself with the center of a landing spot. And once it gets the confidence, it slowly decreases its altitude for a safer landing. And here, our aerial vehicle has landed in its first landing spot. Saving the coordinates, you can see the coordinates in the HUD, spot 1. Before taking off again, verifying all the systems, waiting for a few more seconds. And it's going to take off again, increasing its altitude up to 3 meters of height. Moving the camera. Now, if we all can observe, we have a status LED in the back side of our ANAV. It's for, sometimes it happens that base station might lose the connection with ANAV, but the main pilot can still know the status or a mode which our ANAV is in. So there are 4 modes. Red, when the status LED indicates the red, it means it's trying to align itself. And when it indicates greens, it means it's navigating. It is in the navigation, spiral navigation. And when the status LED indicates white, it means it is trying to land on the safe spot. And the blue indicates takeoff mode. And there is one more mode which is yellow, which indicates that our ANAV has detected the yellow border and trying to move backward slightly.
So in any case, the yellow line would not be crossed over. So it detects and it pushes itself back because it has detected the visual fence. As you can see, there are additional lights connected to the ANAV. So this is to improve the landing accuracy. When it thinks that there is a safe spot, it will try to land and then it will turn it on its light. So as you see, he thinks that there is a spot, he tries, but while he lowers it down, it disconnects, it gets away.
And here, our aerial vehicle has detected its second landing spot. Saving the coordinates. Second spot coordinates, 5.9.
We will have a little prop check because it has just from a visual side.
You can move it if required.
You can move it.
Okay.
All good?
Yes.
We are all good. We can go for the third spot.
Third spot.
So now it will take off again.
Increase its altitude.
Manual intervention has been taken. So it was going to land and the RC has taken the control.
No, RC is doing anything?
Yes, sir. We just had said that a manual intervention has been taken. Yes, sir. The manual intervention was taken because it was going to land on the stones, and then we just aborted the landing. And we will again start from the second zone.
The task can again initiated. Now our aerial vehicle is in the navigation mode. Slowly moving forward in search of next safe spot.
We will be taking another manual intervention. The battery has been low, so we will abort this run. We will again start from the home position and we'll go for the next run with the battery change. He's now controlling with the RC and he will land on the home. Yes, sir. So low battery was triggered. The beep is for the low battery. Yes, sir, manually brought out. Sir, that is after this beep. Because he not completed the current mission, so that's why. Yes.
Just 1 minute.
Yes, sir.
What is the purpose of your LED lighting? Is it required here?
So what we intended to with the LED status lighting was that let's say if any case the comms has been lost. So the pilot which is manually controlling, he should know the status.
No, I'm not telling that. I'm not telling the red and the green.
Okay, okay. So what we did when we were practicing and we were configuring this drone or the ANAV, when landing, the optical flow quality which is required to center from the center of the safe zone, it loses its quality. The confidence of the sensor gets down because it gets dark when we are landing, and there is kind of a minimum reference. So we added additional lights. So while landing, the lights turns on and the quality of the flow sensor gets increased. So we can center the ANAV to the center of the safe spot.
Okay, in this spiral flow algorithm, won't there be a rotation? It always moves on.
Yes, sir. It maintains the heading, the XY direction. Yes, it always maintains. No, sir, it will not rotate. So the search pattern which we developed is because the similarity algorithm which we are using for the safe spot detection, it requires to be heading to be same.
That means the camera is looking forward, but it is moving backward. Is it that way?
Which camera, sir?
Your camera's in the front.
Sir,
looking forward.
no, sir, that's looking down.
Down.
Yes, sir.
Forward and down.
Yes, sir, forward and down.
But it is moving backward.
It's moving forward, sir. When the spiral search comes to that end, it will go in backward direction. Yes, sir. So, sir, what we did when it is on the landed position, the camera position in front. So when it takeoffs, it turns the camera down so that every tracking is according to the top-down perspective rather than the front perspective. Only while landing and takeoff, it turns its camera so that there should be no false detection. If it is completely down, it gets like black image or the black depth frame. Are we ready? So we will give a 5 minutes. He's just verifying everything with the RC again. He will take a small manual file. Tavish, check the props also.
Sir, you think we can ask him to change the heading and directly target that? Otherwise, we will have to say, suppose we have already given him the marks. The first attempt is a group, second attempt, third attempt. Only that one which he asked us.
Are we good to go? Yes, sir. We are again will be taking the flight autonomous, and it will follow the every 3 safe spot.
Are you planning to again go to the safe spot or which safe spot? Will it try again or?
Yes,
How
sir.
does it
It
do?
will again a same safe spot.
Okay.
So because we actually, so the spiral search pattern is not programmed likewise.
So, okay.
Yes, sir.
Sanjit,
Yes, sir.
if you change your heading, whether it will try the other spot first?
Sorry, sir.
If you change the heading, will it try the other spot first?
Uh,
You want to try or? Okay, I leave it to you.
Okay, sir, I will just discuss with
I leave it to you. Just decide.
4.6 spot, 4 start currently.
Third spot, nearby, this third spot is nearby.
So I asked for the position change.
You are confident to keep where the screen is towards the screen?
Okay.
Yeah, no, extra.
Excuse me, sir. So we will like to attempt what you asked, that we can start with the heading directly to the third safe spot. Yes, sir. We have to just change the position of the roll. No, sir. Heading and position also.
Okay, the way it is.
Okay, heading also. Only heading, not position change. Only heading. It will attempt the first in that direction. So that will be slope. Yes, sir. Tell me when we are autonomous ready. Tavish, are we ready? Autonomous? Padmesh? Autonomous ready? Okay, 5 minutes. headphones in the ear. So this actually last what happens if there is something happens? You have to show. Team, are we ready to go? Team, we are ready to go. Tavesh, okay? Sir, we are ready to go. We will attempt in the different heading.
Yeah.
And we will land on the third spot, the safe spot.
Okay.
Yes. Yes, ready.
The autonomous task has finally initiated. Again.
There is a little technical glitch. We'll just find it out.
Okay, inform if it take time, you inform otherwise.
Yes, sir.
We have just restarted the ANAV. It was actually standing very long time on that, so sensor got fogged up with the values. Excuse me, sir. So after this, we will be attempting back to the home.
Sorry?
So once we landed on the slope, we will be going back to the home.
Okay, okay, you are only
Yes.
one landing and okay,
Yes.
fine. Correct. In the same line, semi-auto. The same semi-auto will consider.
We'll attempt this in this pattern. Sir. Team, are we ready? Tavish, Padmesh, Danesh? Okay, we are going for the autonomous flight. In this heading, we will attempt all the 3 spots in the order, where slope first, second this near one, third the first one, and then back to the home.
So initially drone will go forward. So there are 3 conditions. Either it will go by 12 meter or by the yellow line or by the safe spot. If any 3 has reached, then it will stop going forward. It will align to the safe spot. It will land to the safe spot. It will again take off after 20 seconds. And it will again continue from the point it has left. So it's 12 meter or the yellow line has not reached. So it will again go forward. Then again come on the right hand side. Okay. Till again either safe spot, 12 meter or.
So ready?
Go,
yes.
Go.
Padmesh. ठीक है.
The autonomous task has initiated.
The drone, actually the ANAV didn't receive the command properly, so we will restarting again. Same, nothing to do, just start from the programmer side.
Autonomous task has initiated. ANAV.
Tavish, requested to take a manual flight a little for a height. Take a check and then we'll go again.
We are taking a hard reset again. Sensors are giving wrong data.
Is there the sensor?
Hardware change if they want to do, they can do.
So we will take a hardware change because the motor, I might have been misaligned.
Okay, fine. You come back in the
Sure,
return
sir.
queue. Okay, take care. No issue.
Thank you, sir. Thank you so much.
Quickly come back.
evaluate because it is more than one. No, I was looking at him. So it was like, sir, this landing, I mean, it is an incremental safe spot identification algorithm. They are not scanning. So they are going, if there is a small thing, they will make an increment. So there is no localization. It's clean. Last distance was almost like sir will not evaluate.
Team is ready? Ad Astra? You are the person? Your name? Prabhakaran, okay. You have to choose a home point as well as heading. Just choose the one of them. Okay. So, your point is 5. Okay, this you choose one more. So south facing. So it will be facing this direction. Point 5. 5 also is there. 5th point also. Yeah, any point is okay for you. So you know the requirements, isn't it? From the home point, you should start going up and minimum 2.5 meters and look for the safe spot and land to all the safe spots, any order, and go back to the home point. That's the first requirement. And you also have to see that the periphery is marked with yellow. That also you have to take care. That is one thing. And you have 3 attempts nominally. So people are trying, but that is dependent on how it goes. Okay, 3 attempts can be made. And nominally you have to do autonomously from start to the end. And in case any difficulty is there, you can tell what type of change, what type of intervention you want to do. Safety wise, you can have some intervention. Okay, you can have some intervention. And if you need some requirement of illumination, you have to tell. In case lighting is required or some change is required, that you have to tell. Okay, and if you are ready, straight away go ahead with that. And you can just give a brief introduction on the system and then go ahead. Okay. Go ahead.
Hi all, my name is Prabhakaran. We are from team ADA staff, Sairam Institution. Okay. Actually, our drone consists of an optical force sensor and an LiDAR down facing for that. Also, we have a stereo camera Z2i for the safe point identification. The major stack we use is Jetson for our main processor. For the slave, we use Pixoc to navigate over that for kind of drone navigations. For safe spot identification, we use RANSAC algorithm with the help of PCL. We will be finding the safe spot. We also have an angle threshold to land on the slope. That's it.
Okay, Prabhakar, you are planning to do autonomously, correct?
Yeah, yes.
Okay, you will start from the home point.
Yeah.
And how do you scan? What is the plan of scanning?
Actually, since the area was comparatively too short, so we have been moving through the yellow border. Just we use a bounce algorithm where which the yellow border is detected, the drone automatically bounce back from that such that it keeps roaming over the entire area.
Okay, now it is kept there and it is starting from southbound.
Yeah, okay.
Is okay for you? It will go immediately yellow, it will come.
Yeah, okay, no, it's no problem. Okay.
Okay, if you are ready, go ahead with the plan. Okay. Okay, and announce, somebody should announce what is going on.
Yeah, okay. Yeah, okay. Let us check actually. We are planning to ensure that yellow is correctly directing or not. Actually, it takes some minutes. We can able to detect our yellow actually. We are setting up a drone for autonomous.
Prabhakar, for safety purpose, you are having that RO control? Safety?
Yes, sir. Yes, sir.
Who is having that?
I is having it.
Okay, okay, right.
Check. Check, check. It's for pre-check, then it's for telemetry UI data. It's for telemetry. It's kind of shows the entire algorithm says what algorithm will be working.
Are you ready, Prabhakar?
Yeah.
Ready, yeah? Team is ready?
2 minutes.
Okay.
Actually, we have been doing a pre-check. Is everything okay?
We are going to be launching the node. The drone will start in about a couple of seconds. Takeoff. We are exploring. Yellow detected.
Actually, in this image, you can able to clearly see the yellow regions are masked out, and the green spot indicates it's a safe spot. If it was a red, then there will be a stone. We will be searching a convolution matrix over here. The matrix consists of green. Then the rover automatically align. Then the drone will be automatically aligned to the safe point actually. Safe spot actually identified. You can able to say safe spot is actually identified. we will getting the command what direction we want to be going to reach the safe spot.
We are moving again to forward as spaceport did not get a command.
Actually, it want to be find at a safe spot, but it started looking for some other safe spot. Actually, since this area has overexposure, so our algorithm can't able to predict it's an yellow border. That's why I think so. About actually we planned to abort since the yellow border was okay. Actually,
okay, it could not be stopped. Okay, okay.
Actually, due to the light, the yellow border was overexposed. It looked like white actually. That's why it's crossed over.
Okay.
Can we?
You made to switch off some lights.
Actually, we checked over here, but since there was an high exposure, it's can't able to detect.
So some lights you made to switch off in that case. Prabhakar?
Yeah, actually, light reflection. Yeah, actually, the white light is reflected over the yellow region. Yeah. Yeah, okay. Yeah. Yeah, okay, that's the reason actually. Here we can able to play this. We text over only that area and we have been confirmed it, but unfortunately the light was too nearby. We get more exposure over there. Yeah. Yeah. Actually, we will be splitting that area of 0.25 meter across 0.25 meters. Actually, each green box represents it's a safe place. That is 0.25 meter cross 0.25 meter. Yeah. Actually, we have been searching for a convoluted matrix over there. It was about 4x4. When the grid was 4x4 matrix, we will be considered a safe spot and we will be landing over there. Okay. 4 safe spot. Yeah, sir. Actually, it got some kind of the prediction was not so clear actually over there due to some lighting. I think so. It's a lighting issues. The safe spot keep on switching. It comes and goes. It comes and goes. That's what the problem. Yes. We came. Yes, sir. Actually, in our testing, we didn't get this kind of distortion movement. even actually we can able to identify the stones correctly, whether it's an obstacle or not, but kind of bumps over, maybe it suffers. Yeah, actually, I think it's because we try to fit a plane in that specific box. If a plane is fitted over in that position, for example, in the image, we will be trying to each square box will have 900 points. We will be trying to fit at least 850 points over there in the plane. It will be fitted. It is marked as a green, or else it will be marked as a red. Maybe this kind of thing can cause, because in a slight slope, we can able to detect it's a slope. Even at a slope, we will take it as a save point. Thank you, sir. Thank you for the lead. Actually, we be moving slight manual for is it okay good or not. Actually, we have a crash right. We have been calibrating once again. Just we need to test it's okay manually or not for that. Okay. Yeah, actually, we will be flying over a 2 to 3 minutes flight over this arena. Is that okay? That's what trial for either the drone is properly responding on the drone is properly responding or not. Actually.
In order to calibrate our drone, we are trying to take it off and go around the arena. Checking the video feed, we'll calibrate the drone and then we'll start it as autonomous mission.
We just want to traverse over that area for just like 2 minutes. Okay. Manual control is operating, sir. Actually, bit slow. It's working good actually. We'll be starting autonomous mission once again. Yeah, it's a spare battery we use for testing. Yeah. Yeah, okay. Yeah, we ready. Yeah, we are ready. That's why we face the drone in opposite direction. We have planned to place in south, but for testing we placed this side.
Okay, you complete what you want.
Yeah, okay.
Bishop is 6:45, enterprise 7:30 immediately we can have the breakfast. Then 8 to 1, 8 to 1 and 1 to 1:45. Instead of 12:30 to 1:45, can have from 1 to 1:45. He doesn't make any. You change our spot, it will not work there. And you can tell next day. Now they after the border. No point in further continuity, right?
Okay. Okay, since no, just heading alone will change. Okay, you change because
We are going to restart the drone. I will tell you. Take off to 2.3 meters. We are going to explore. It has found a safe spot.
No, actually, it's failed to detect. You get the point over here.
Reach.
Actually,
We are
if the point is
going
not
to
reached,
landing.
safe point is actually reached. Yeah. Where? Yeah, actually, next one, next one. We'll see.
Okay, okay, okay.
No, 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 actually.
We will wait for around 20 seconds and we'll be taking off. Exploring.
Landing was autonomous. Sir. The yellow is detected, the drone is turning over. The drone is currently in manual.
Aborted.
The model is, the drone is controlled over manual mode for safety purpose.
Okay, Prabhakar, okay, good. Okay, the last thing was manual. Okay. After seeing the safety.
This was manual actually, previous one was autonomous.
Okay, fine, I got, okay, okay, good. Okay. Yeah. Prabhakar, it's okay?
Yeah, okay.
Okay, it's okay. No, you have anything else? It's okay. That's fine. Prabhakar, it's good.
Yeah, okay. Thank you, sir.
You explained some. What are the configuration you explained? Good. You demonstrated one autonomous going up and landing. It's
Yeah.
good. You identified. Yeah, yeah. Okay. So can you explain the configuration of the system?
Actually, our drone is equipped with an optical force sensor and a LiDAR down facing for the kind of its pose. It's kind of pose and altitude.
Pose.
We also have an IMU for the yaw value. We use Jetson for master control and Pixar for control, slave control, kind of drone navigation over there. We use.
Yeah, go ahead.
Okay, we use RCL. Sorry. We use Ransack for safe point navigation, where we will try to fit a plane over there. If the plane was, it's kind of given thresholds. In between the given threshold, you have two thresholds filtering. One was an angle threshold, and another one the number of points lying over the plane. if it made up, it will be marked as a green. After that, we will be finding for kind of clustered greens, each of size 4 cross 4. If the point was met, it will autonomously land, align over it and land. But here we have a problem because of the yellow border. Here we have the problem because of the yellow border. We can't able to turn over the yellow border. Okay, we make our threshold little more for it.
Okay, the last also why it went beyond that? It initially identified, later it could not identify.
Actually, it's keep on turning. Actually, we speak.
Okay, okay, it is quite agile, it is moving very fast. Okay, okay. Okay, very good.
Yellow.
Okay, 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 okay.
Since that all was red, it kind of confused with the yellow.
Okay, okay, these are all smaller ones. Yeah, really. Okay. Oh, a lot of green things were coming on your, yeah. Okay, okay. Okay, okay, okay. You have two more at the safety, because if there's a power loss or battery low, it has to come down. That if you are ready, you tell, otherwise.
Actually, we may autonomously we have landed in a single phase spot, but unfortunately, due to some issues.
It's okay. Good, good. Very good attempt. Nice, nice. Everything is done
Thank
nicely.
you.
No, if you are having the safety demonstration, you do it. Otherwise, you got it.
Actually, our team was on it.
See, you have put that mini linear actuator adjusted landing gear. Can you explain that?
Yeah, actually, we for landing on the slope, we have been planning to attach a lander, which act as a linear actuator, and while the drone gets landed, we'll be turning on the actuator by getting the slope from the. While finding the safe spot, we'll be identifying the slope of angle slope of it. According to it, we planned to on the linear actuator to align over the slope so that it can stand straight.
That is autonomous, or you have?
Yeah, we plan to do it autonomous, but unfortunately.
Okay, thank you.
Thank you.
Is there safety demonstration or it's okay? Okay, it is fine. Okay, it is fine. Okay, good, good. Okay, we'll call next team.
Actually, we use separate system for. Actually, we used a separate system for kind of actuating the post. The drone stability was entirely. The drone stability was entirely depends upon the optical flow on the lidar. Actually, for X and Y values, we get the features from the land by using shift algorithm. And with respect to the features, the drone finds whether it's sliding over or not. And by using the lidar, we can able to identify the height. We have a separate magnetometer for on the top. These values will be combined with the PIXOC magnetometer. We use Kalman filter to fuse it, such that we get better stability over the drone. Actually,
we are using computer vision, sir, and we are assigning a HSV range. If a couple of pixels, we have just defined a threshold, fall within that range, in that place, then the drone will take a left turn.
Actually, it's the major problem is the accuracy was too small. So if it was morely light based, it will be not detecting over the yellow spot. But here, what happens is we didn't work on red soils. So even our HSV range consists of red also as a border. So it's keep on rotating. So maybe we tried over in red soils, we can able to adjust the HSV value. It's kind of. Actually, we plan to get the yellow value into our range. That's it. But we
one comment is the stability of your platform is very good. One is like the way it used to hold its position and orientation, that was really good. So is there anything like you have observed why it is that good?
Actually, it's a camera over here. It's a point camera. From this, we get the feature of the land area.
Calibrate our drone, it will take around 3 hours. That is something we expected, but I think we didn't have that opportunity here. It is because of the optical flow sensor and the IMU, sir. We have optical flow sensor. Yeah. The soil. Basic calibration is done, perfectly done. Yeah. And
that was remarkable. What I could observe was it was remarkable that it was holding its position so well.
Yes, sir.
But now some drift is there. That's where we are actually doing.
No, sir. No.
It is saturation. It was a very good effort. I appreciate the team.
Yeah, which team has team? Your team is? Oh, Trailblazers. Okay, I understand you know the requirements. So you have already picked up your location and the heading, isn't it? So you have to start from the home position. I think it is fixed there. And then you should go to minimum height of 2.5 meters, and you have to identify the safe spots and land on 3 of the safe spots in any order and go back to the home. That's the requirement. And you are aware about the periphery is marked by the yellow, and you should take care of that. And you also have 3 attempts nominally, okay? So you can consider that. And the requirement is to go fully autonomous right from the go. Okay, if you have some difficulty, you can do some semi-autonomous. Okay, let it identify, then you can find if it is safely identifying. Okay, so you can look at it, and if you need any illumination issues, now itself you can take care. Okay, if you have any finding identification problem, you have to reduce the light or something, you have to tell now. Okay, and then for safety purpose, you keep that RC for switching off the system in case it goes beyond the expected limits. Okay. So other than that, everything should be autonomous. Okay. You briefly explain. If you are ready, you can go ahead. Otherwise, you briefly explain the system, then go for the. Yeah, you briefly explain the system. Okay.
Good evening, everyone. I am Akshat Agarwal, and we are Team Trailblazer from the LNMIT Jaipur. We have developed an ANAV. Let's start with the mechanical part. We have completely built the frame. We have completely built a custom frame out of carbon fiber. We are not using a commercial frame. We have made it out of 3D printed parts and carbon fiber. And for onboard processing, we are using a Jetson or a Nano. And for the flight controller, we are using a Cube Orange Plus. For the safe spot detection, we have Intel RealSense D455 camera, which is basically a depth camera, a stereo depth camera, which can create a topographical map of the whole arena and find the safe spots from it. And for the stabilization of the drone, we are using 2 sensors. One of them is a PMW3901 optical flow sensor, and the other is a LiDAR sensor, exactly TF mini LiDAR. This is a 1D LiDAR, which basically helps with the height, by stabilizing the height. And the optical flow helps with the stabilizing of X and Y coordinates, X and Y axis, basically horizontal. So by combining both the optical flow and LiDAR, we can hold the drone at almost no drift, approximately 5 to 10 centimeters at max in the wind conditions. And talking about the algorithms and the traversal method, we are using a lawn mover method. Basically, it starts with the location, it travels to the origin. It will choose any corner, it will travel to that, and it will start a lawn mover pattern. It will travel the whole arena in steps. Once it will go left, then in front, and then right, and until it completes the whole arena. After complete. Sorry, sir. Yes, sir. So for finding origin, we are basically asking it to move to the extreme-most left and down, following the XY coordinate system. So. We detect the border. Yes, sir. Yes, sir. After detecting the border, we know we are in the corner. When it traverses, it again detects the border. If it is moving right, it will see for the right border. Whenever we reach the border, it changes to front. It moves a specific distance, then it again comes to the left, and so on repeats. When we detect the top border, it will stop since the whole mapping is completed. After that, the other node picks up, which takes the whole map, saves it in the local storage. Yes, sir. No, sir. We first traverse, and Yes, sir. Once we create the whole map, we save the whole map in the local storage. We load it into other node, which takes a couple of seconds to identify the safe pods. Once it reaches the safe pods, it finds the clusters, because in some times when the actual safe pod is a little bit bigger than the specified, like it could be 1.6 meter. There might be many safe pod detected. For that, we are clustering all of them. If they are too close, they are considered as a single point. So we identify the 3 safe pods. It gets delivered to the autonomous control again, and the drone moves to each point and brings back to the home location. Yes. Sorry, sir? We are basically scanning the whole map, whole arena. Okay. We are, yes, after completing the whole map, we take a median of the whole map, because there are many obstacles. We take the median, which basically tries to find the ground level. After finding the ground level, we implemented a algorithm called transect and plane fitting. It basically picks up random points on the whole arena indefinitely until it finds places a point. It creates a square of 1.5 to 1.5, or we can change the settings too, and it sees what are the deviations in height. We can also set that manually, like we can allow around 6 centimeters. We can also allow it to be 10 centimeters, or we can set it to 0. Once it matches, fulfills all the conditions, it will consider it as a safe pod and send the coordinates. And the coordinating is
once it will move along the border, and then it will start scanning, identify the safe zone, and land there.
Yes, sir. First is it will scan the whole map, then start identifying.
Scan the whole thing.
Yes, sir.
And then only land, is it?
Yes, sir. If
ensure you would have got the coordinate of that safe area, no?
Yes.
You ensure that you go to that area only, having an IMU also.
Okay, sir. So, like starting from the home position, we consider it as a 0, 0. The home, where we start. Taking that reference, the map which is created actually picks up the real coordinates. Like if we are moving 9 meters, the map will actually depict that the dimensions of it is 9 meters. So we can pick the real coordinates of the system. Yes, sir. All this is automatic. Yes, sir. All this is automatic. It is in series, but all of them are automatic. We don't have to interfere with anything.
Hello?
So what are the things you are going to do? Fully autonomously, are you going to demonstrate now?
Yes, sir. We are trying for fully autonomous. We just click the start and it will complete the whole task.
Okay.
Yes, sir. Yes, sir. We are aware. Sorry, sir.
In case autonomous is not working, semi-autonomous also you can opt for.
Could you please explain what could be included in the semi-autonomous?
So if you are able to identify the safe spots,
yes, sir.
if scan and identify safe spots, it means the job is done.
Yes, sir.
Then if you are not able to go there, it is considered
semi.
Okay, so you can manually feed us.
Yes, sir.
Identification is more important.
Yes, sir. We are basically saving the whole map, so we can extract it and run the algorithm. Same.
Show how you.
Yes, sir. We will show it. Yes, sir. Yes, sir. We have 2 safety features. One is the battery link, battery low, and the other is radio link lost. For the current task, we are basically landing. If any failure occurs, if the remote gets disconnected, it tries to land below. And same for the battery level. We can modify the battery level. Currently, we are set it to 15% for the warning and 10% for the landing. Once it comes to 15%, it beeps and indicates that to the ground station. And if we don't manually land it, it will automatically land it itself. So for border detection, we have trained a segmentation model. We have built an arena on our campus. We have trained a custom model in which we took about 200 images of the whole arena. We marked the borders that we marked the area of the borders. We trained a custom model and we feed it again. So
technically used for medical image segmentation, like brain imaging or something like that. So we take inspiration from that architecture and try to make a unit which is consisted of two CNN models. Like one first go to take the image and downsample to the some features, and then upsample to the segmented image. So when we got a segmented image, it is a black and white image. After that, we are detecting that there is a border, and so that's how we're doing. No, sir.
Is lighting condition okay for you, or that you want to change?
Yes, sir, it will be okay.
This is okay. Good. You required lighting conditions.
Sir,
That
lighting.
side also you required or not? With red.
Sir, saturation based things are totally removed. If there is some slight change in tone of the yellow color, like in our college when we are testing, it's an open area. So when we are testing in afternoon, so there is too much light. So previously when we are using normal image processing based systems, so there is too much exposure. So saturation got too much high and hue correction not working too much fine. That's why we shifted to unit based system. So if there is too much lighting, for example, that yellow border get to like kind of yellowish tint, whitish tint. So it gonna detect that it's a yellow border.
That you have
Yes, sir.
Okay. That.
For depth.
sorry sir, resolution. The camera needs to be minimum at 60 centimeter above the ground.
Resolution, your depth resolution.
Okay. We can measure very accurately around 1.5 to 2 centimeters. We can go even 1 centimeter, but sometimes the sharp corners can be recognized as like fillets.
So for detecting flatness, like he's explained that, first we are mapping the whole arena. So when we got our arena, so we just load it to the node, which is using a RANSAC based algorithm. So what RANSAC actually do, it takes some like if I initiate, it take random number of agents, like for example 1000 agent random points, and traverse in the arena and try to find the flat surface. So how you can say like if there is a, can I take a paper to explain? Can I take a piece of paper to explain you? So for example, if our agent is somewhere like here and there is a flat surface, so it will try to move in a circular way and try to find a flat surface, how much flat surface is there. So for example, if it in H and it find that there is too much change in slope or too much deviation, so it will take that there is a end of the system. So that's how our system technically taking we are taking 1000 random agents. So sometimes what happened, like if I take this system, so like for example, if there is 2, 4, 5 agent got initiated here, so there must be 3, 4 cluster we created. So then we are taking some machine learning algorithm like we are using currently, K means clustering. So using that algorithm, we just take that whole system as a one. So number of cluster got removed, reduced to 3, and that's the optimal number.
You are directly go to that autonomous navigation, or that directly into okay.
Sorry.
You are any.
So I'm very confident that it should work, but due to some weather conditions, we might need to calibrate because there's a lot of pressure difference in Rajasthan and Bangalore. Yes, sir. Yes, sir. We have actually tested it on the practice arena, and it is working perfectly. So we assume it should be working.
Satellites are essential tools in our modern world. They facilitate seamless global communication, gather valuable scientific data,
Question number 1, south, heading south, one south. Okay, so you know the competition, isn't it? Yes. So from the home position, you have to hover beyond 2.5 meter, hover or scan for the safe spots. Okay, autonomously you should find out and identify the safe spots and land in each of them in any order. Okay, and then reach back to the home position. This is the primary requirement, and the edges are marked with the yellow color that you are aware. Yeah, beyond that, it's all unsafe regions. Okay, and other thing is you have 3 attempts. You can do it, and actually 45 minutes. Within the 3 attempts, you have to try everything. And then other thing is, it's preferred to be fully autonomous. In case you have any issue, you can switch to the semi-autonomous mode. If you are able to identify, is much good. If you are able to identify and demonstrate that you identify the safe spots, it's good. And then you can go for
So right now, right now we are actually, okay, I'm telling. Okay. So right now we are setting up our UAV and doing the sensor check, the final check before the starting of the mission. And before starting, we will take a manual takeoff and land, after which we will commence with the autonomous mission. And yeah, and our safety guy is in the arena.
West, west, okay. So I think you know the full competition requirements. So there's a home position which you have selected now. From there you have to over up to 2.5, whatever, minimum 2.5, and identify 3 safe spots and land and take off and back to the home position. And you can tell if you need any illumination requirements or anything. You can illumination requirements, if there's any requirement or some lights off or something required, you can inform. See, another thing is you have 3 atoms. You can just see that. Based on that we'll see. In case of any small thing, you can always do that. And see, one is fully autonomous. If you can try fully autonomous, it's okay. And if you find some safety or reasons, you can always intervene and go for a semi-autonomous. If you are able to demonstrate safe location is more important. That also you can demonstrate is okay. And fully manual also is one more case. In case you find any difficulty, okay, you can just intervene to make it safe. Okay. Okay, go ahead. You can just briefly explain the system. Whenever you are ready, you can go ahead because for your the system, if there is any battery requirement, you can go ahead. Okay. Okay, fine.
Hello. Okay. So.
Just 1 minute. Do you need any terrain should be uniform, made uniform?
Any requirements? No.
It's okay, or we have to fill some sand. Okay. There is some.
I think it's fine only, sir, because it's not any rectangularly.
Okay, it's good enough. Okay, fine.
Partially filled also.
Okay, fine.
Okay. Hello. Okay. So I'll start introducing my.
You can introduce the what you are going to do and minimum, and when you are ready, you can go ahead. It is just if suppose if you have to, your battery or something is requirement is there, it should not discharge. You can go ahead with this. Meanwhile, you can just explain about. Meanwhile, you can explain about the system what you are going to demonstrate.
So can I also give a brief introduction of the team also?
Yes, yes, definitely. Go ahead. Go ahead.
Hello. Okay. So I am Anuj Srinivasan. I am the team leader for Team Anveshak IITM for ISRO Robotics Challenge 2025. So currently, yes, Srinivasan. So currently we have 5 members over here. We are supposed to have 6, but one of them had a fever and wasn't able to come. So I'll start by who exactly we are. We are from what we call the Center for Innovation. It's a hub in IIT Madras that furthers innovation in robotics and other engineering aspects. So I am personally from a team called Team Anveshak. We are a space robotics team. And this name came from that, but it's not only team members of the Anveshak. So there is another club called AERO Club, and that is the Aero Modeling and Aerial Vehicles Club for IIT Madras. And their help has been indispensable over here. They have experience in aerial robotics, and we have a competition experience. So that is why I decided to collaborate and come for this competition. So that is the introduction regarding us. Now, I guess I'll start with the actual system itself. We're using a quadcopter with powered by a 4S lithium polymer battery. Currently, all the cells are 100% charged, about 4.2 volts. And the idea that we're going to do is we're going to take off from our, I'll explain the basic flow of control. We're going to take off from our home position and then map the arena. And from there, we can get the safe spots and come down and land on each of them, and hopefully go back to the home position also if the odometry lasts. So how we're getting this odometry is we use our Stereolabs Z2i camera over there. It's a depth camera. we use that for something called visual SLAM. It's basically visual simultaneous localization and mapping. You'll be able to map our environment while also moving around it. So that is how we are getting all of the positions, and that's how we can run a clustering algorithm on whatever depth map that we get to get all of our safety spots. And our
So entire thing you are going to plan autonomously from the go one from the go?
Yes, if everything goes well, we will be able to pull this off completely autonomously. Okay. And I would like to also say that when we are doing our own test runs in our own arena, in our institute, we were able to get multiple successful runs all the way up to the third safe spot.
Okay, okay. In the periphery also you will be able to identify with the yellow marking. That's also part of this.
That will be done. And we use that to actually localize, more or less.
And two more tasks are there just to demonstrate the safety. If link is there, link is down, you may have to come down. Probably you would have seen that. Safety, and then battery safe also, it has to vertically come down. So that also you can demonstrate after this.
Yes, understood.
Okay, okay. So if you are ready, you tell. Otherwise, some questions you can take means okay. Otherwise, if he is ready, go ahead with that. If you go ahead with it, yeah. And you announce the activities. Somebody, whatever you are going to do, you please announce. Okay, go ahead, please. All the best.
Thank you.
You can also say what you are going to display. Will you be able to display the safe zone, all that? The base computer, are you showing something? You just. No, the base computer, are you going to show something? What is happening? Yeah, he's going to, maybe he will connect this camera live. Okay, okay.
You will shoot your laptop.
Okay, for any safety purpose you can use. Okay, fine, fine. Yeah.
Briefing the chairman. Briefing the chairman. Tomorrow it looks chairman may come. Adjust பண்ணி முடிக்கணும் அதுக்குள்ள 6 மணிக்கு இன்னைக்கு 10 முடிச்சாதான் வந்து நாளைக்கு படிக்கலாம் இன்னொரு கூட the advantage is tomorrow no inauguration. Last minute everyone attend normal direct ಇಲ್ಲ ನಮ್ಮ ಕಟ್ಟದ ನಾವು ಕರೆಕ್ಟ್ ಟೈಮ್ ಬಂದಾರಲ್ಲ ಎಷ್ಟೋ ಸಮಯ ಸರ್ ಎಲ್ಲ ಕರೆಕ್ಟಾಗಿ ಕರೆಕ್ಟ್ ಇದೆಲ್ಲ ಇದು ಡಿಪ್ಲಾಯ್ಮೆಂಟ್ ಎಲ್ಲ 9th ಒಂದು ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ ಡಿಪ್ಲಾಯ್ಮೆಂಟ್ 10th ಡೇ ಇಲ್ಲ is already 8 9:50 correct 15th should be over like that. August 15th along. Really record success. Correct. The window. Even for the entire country as well as world. So much money spent there.
Excuse me, sir. So here Sudhin Raj from our team will explain what all the windows and all the terminals here. I'll pass on the mic.
Yeah,
So,
if
this is the odometry position of the.
if you are ready with the demonstration, you can go ahead. Because if there is a constraint, you go ahead with that. Okay, you decide. Much better. They have made an effort. Good effort. Correct. Correct. They have made good effort. Correct. Professionally, they are made. Easy. Okay.
Excuse me. I'd like to point out there's been a small issue in our. Can you hear me? Hello.
Yeah, go ahead. Go ahead.
Okay, so there's been a small issue in our remote controller, so we're slightly going to recalibrate it. It's going to take not more than a couple of minutes. So I thank you for your patience.
takeoff height.
Srinivas, can you explain what has happened?
Yeah. Our line detection and corner detection failed, so we are retrying the mission. Yeah.
Okay. What has failed?
The line detection and the corner detection has failed, sir. The yellow line detection and the corner detection. Yes. Yeah.
Yellow line detection.
Okay, we are ready to fly one more time.
Okay.
The drone has taken off.
It has identified safe spot. Did it identify?
No, sir. Still, we didn't scan the area.
Okay.
Sir, so we are about moving in the process of line detection. So what is happening is that we have kept the distance threshold for the line.
So as of now, we have detected 2 of the 3 safe spots. Now we are going to land directly on the 15-degree slope safe spot, and then we will do RTL back to home position from that. And after that is like succeeded, we will go on for a complete entire mission. That's it.
You will be able to do autonomously that?
Yes, that's the aim. Sir,
battery is having support?
Yes, sir.
If the batteries,
batteries are fully charged, so
fully
it is.
charged.
The previous 2 were autonomous.
Oh, that's true. Now we want to do this autonomous only?
That's it.
Okay, go ahead. Yeah.
So we have actually replaced the battery, and as he told, we will just go for that elevation, and from there we will do RTL. If it works completely, we will go for the all 3 safe spots.
Okay. You do in one attempt, okay? Go ahead, go ahead.
So the search has started. It should detect the elevation. If it has detected the elevation, if it lands properly, then we'll go for the... Okay, so it has landed autonomously. Now we will go back to the, return to launch, return to home position. Right now it's trying to go back to its home position. No. No. Let's see. The drone is stable, so let's see. Take manual control.
Sir, we took manual control.
So we have taken manual control, and I will just. Okay. So the edge flow sensors, I think because of the dust, it started swaying in the other direction. So we'll try to fix it, and we'll start it again.
Can you just tell what you intend to do now?
So we'll do this, or we'll just go back to the registration.
No, you need to say you want to again repeat all the things autonomously.
Yeah, and then go back to the home position. Actually, yeah, we'll try to do that. Yeah.
Again, you will identify the
Yeah, we'll do for the elevation, then this one, then this one, then go back.
What change you are doing?
No, we are changing. Actually, this change what we made, as I told you, we have changed the the elevation of the camera offset because we are not confident about the landing thing. It breaks or all. So as these 2 safe spots were safely detected autonomously, we went for that.
With that elevation, will it be able to identify these 2?
Yes, sir. That is there because it is actually given from certain range to like 15 degrees. So offset was given 16 to 18. So 0 to 16 to 18 was given. But the problem was I was trying to play it on 10 and 11. The reason being, if it lands and breaks something, so that would be an issue. Couldn't have covered this 2. So that's why what I did was it reduced that. It covered these 2, went back. Now I tested that one. I'm confident that it is landing. So I will do all 3 and then go back to the RTL position. No, yeah. So that's what I told because it was given the angle that was given. The angle that was given. Hello? Yeah. So the angle that was given first in the setting was 0 to 10 because I was not confident in the 15 degree if any issues happens because in our arena that we built, there also we tested on 10. So because of the steep slope, if something got damaged, that's why what we did, we reduced that. We checked for the other 2 safe spots. So now as it safely landed, the 2 safe spots are detected. So what I'm trying to do right now, then we checked for the 3rd one. So 3rd one also landed. So now we are confident we'll go for all the 3 because the damaging issue will be. Yeah. That is 0 to, it was, yeah, we changed that. So now it is from 0 to 16 to 18, the offsets are given. Yeah, so that's why we changed it. Now the thing was, the previously we gave it from 0 to 10 to 11. The reason being it shouldn't detect like.
When you change the battery, whether all these coordinates are stored?
No. It got lost. It was stored in the buffer. We didn't go to the RTL. That's why. That's why we stopped there and went back to the base station. Now then the second mission, what we tried was landing there, and then from there that position we tried to go back to the base station. But something problem with the H flow took place, and like the optical flow sensor, and it swayed in the other direction. So that's why we took manual control, and now we are trying to do all the 3 safe spots, then go back to the return to launch. Yeah, from the H flow sensor, so it started. Actually, we have set the heading angle in the rest in this direction. So we have to change the position. So this way, right? So like this way and this way. Yeah, we can do that, but we have to change the heading of the. Okay, we can do that. Okay. Then give us 5 minutes and we'll just fix it. Give us 5 minutes. We'll just change the head position and then do it. Yeah. But they have to do something. But change the head position and then start again for detecting this one. Yeah, because it is given a raster search, modified raster, so it will go back, detect the land position, it will take the move in this direction and go back in the other way. It was given up to the boundary, so it detects the boundary, it moves, it goes back. Yeah, it will go back. Just the heading we have to change.
We are ready to go with the changed heading.
Oh, okay, sure. Yeah. Okay. We are going this direction. Okay. Can I go to? So we have changed the heading position. So we will start the autonomous mission with the changed direction as suggested by the jury. The mode is changed to guided. Okay. We are starting the mission. So it will try to detect the safe spot. Yes, it has detected. Should land. Okay. So the next spot. It will start in 5 seconds. Okay. Detect the boundary now. Hey, okay.
Okay, thank you. Thank you.
Okay. It's okay. Thank you. Very good. No, they want to ask some questions. Yeah, yeah. If you can quickly, how much time will take?
Not much, 5 minutes.
Good, good, good.
Actually, we want to show something. So how the detection actually works on the drone.
Yes.
Wanted to show that.
Parallel, you can take questions. What was the rationale behind selecting the raster scan mode for scanning? What was the rationale behind selecting the raster scan for the scanning?
Ma'am, raster search we have selected because it covers the entire ground. Like it was moving forward first, then it was moving right, then backward, then again right, then forward. Like this was repeating, and it is covering the more ground. So we chose raster search.
And the thing is, since we have a boundary, we can detect the parts of the boundary and then we can turn. So it's like it depends on the entire boundary and entire arena. So it adapts to it.
Since you are detecting the multiple boundaries, have you used that boundaries information to correct your sensor errors?
Boundaries information to correct.
You know the boundary to boundary distance between the boundary to boundary is fixed.
Yes, ma'am.
And your sensor can have the errors. So have you used this information to correct your
Yes, ma'am.
sensors?
We have taken 30 cross 40, and then we have done the raster search. So if any offset is occurred or error is occurred, then it will continue the 30 cross 40 boundary limit, and it will move back.
Okay.
And before that, if it detects the yellow border, then it will turn right and continue with the raster search. That's it.
And when you were knowing the slope is 15 degree, what was the idea behind selecting the 10 degree slope initial first attempt?
Ma'am,
Actually, for that reason. Yeah. So initially, when the challenge was given, we couldn't manage to meet the 15 degree slope. So that's why we developed in a much steeper slope, and it was because of the rains back in West Bengal, its slope got deteriorated. That's why we didn't take the challenge of going for the first attempt only, because we couldn't find that waterlogging also there. We wanted to show that, but it's not external.
Okay, I would like to appreciate, we could see clearly the raster scan happening very perfectly, and the platform also was very stable.
Thank you so much.
One more thing, you have written that you have developed this sensor, correct? No, self-developed optical sensor.
Yes, sir.
Can you
Yes,
explain
sir.
that?
Yes, sir. Of course. So the reason for the sway and all is that we developed our own in-house optical flow sensor, and it is kept in parallel to the H-flow sensor. Now this doesn't work very much well in low light conditions, so we used a parallel sensor with it. The Raspberry Pi, the microcomputer which we use, switches between them. Now let's dive into the sensor which we build. So actually we found out that old computer mouses used a CMOS array chip, which contained a camera. It is basically a camera, but with a very less resolution, like 28 pixel by 28 pixel CMOS array chip. And it takes images successively and then compares those images to detect the flow. Now we had to find out a mouse which is available in the modern market, which has a sensor which is hackable. So we found out an Acer model, Acer wireless WL something, that it has a PAW3212 sensor, and that specific sensor has SPI pins. We hardwired the entire thing. We removed some pins of the hardware. We removed the microcontroller out of the equation, and then we took the SPI pins and we configured it according to the data sheet with the Raspberry Pi, and then we took the data. And we converted it in CSV file mode. It actually gives an 8-bit data and 1 nibble data of the x-axis delta x and delta y sway as per the requirement of the drone. So this was the sensor which we developed.
Good, thank you.
Now since we developed it in a hurry, we did not design our own PCBs, and also there was some noise, and that's the reason of the sway and all which occurred during the first attempts. That's it. Everyone can't see. That's the issue.
Back there in our line. So basically, this is where so we connected it. So as you can see, the undulations that we made and the detection that is going on. So this is the ROI region. We are taking the Z coordinate, the depth coordinates from there,
And what we will try to do is, if it confirms the frame, that it will be consistent safe. So you will understand where the safe is actually happening. So this is the depth. Here we can see. So if as you can see, 0.1. So we have. Yeah. This is the ending. Yeah. Yeah. That's the thing we corrected the mode and we implemented here. Yes, sir. So basically what we did was we detected 3 parameters: the flatness, then the obstacle, and the obstacle ratio, and then the angle. So based on the combinations of all 3, what we did was we used a naive bias classifier. So what we see, we found out that what kind of land areas are landable and not throughout the inner. So as you can see, yeah. So this is a data set. As you can see, it has total 4,559 data across various regions of flatness, like some steep slopes back in my house, like on the flat floor. So what we see, we found out that between 0.0 to 0.12 of the obstacle ratio, we are getting a perfect flat land. So that's why we are setting it there, and then we are using the naive bias classifier to find out which combinations are giving us the best solution, and then implementing it. In Raspberry Pi, yeah. No. It not based on directly. Okay, no. I'm saying. So what is done? It gives the start command, and then accordingly the drone moves. So if it gives the land, then the base station detects. Okay, if it is taken land, it will land raster. Then it will wait for 5 seconds and take off again because of the telemetry data. And the base station is detecting the boundary, so the brake mode, and it is moving sideways. So that detection is doing for the base station. So it's a hybrid network. Thank you, sir. Thank you, sir. Yes.
Thank you, sir. Sir, the RTL has an offset, like before crashing into the net, it took the land mode. Like it has an offset of about 80 centimeters or 1 meter. So like it took land, but whenever it took land, it sways a little, then get back to its position. So the it got caught in the net. Thank you, sir.
You are ready? You are ready? Yes. So they fly manually and they will scan the area and they will show the identified safe spots. We are asking, sir. No, no, they will tell me. So as per you. As per me also, they only will tell me. Sir.
Yes, Journalist, no? Journalist? You can explain and go ahead. Huh? Can you start? You come this side, if you can. Or you have any issue?
Hello.
Journalist, you tell what you are going to do and go ahead.
Yes, sir. Actually, we are going to do by manually. We are going to fly by manually, but we are going to show how the safe spots are identified and how our idea is to identify the safe spot among the terrain.
Okay, and then you.
So for that, we are giving one command in Jetson. So while flying, we are going to give one command. So after giving that command, it will start to detect the safe spot, and we are scanning by manual.
Okay.
Okay. Start.
Your computer output you will be able to show.
Sir, some connection issues.
Okay, okay. You will show.
We are recording, screen recording.
Okay, fine. Fine, go ahead, go ahead.
Sir? Connection issues. Like Wi-Fi. Yes, sir. Yeah.
Team, you have only 5 minutes to, like 7:15 by if you can show, it is fine. Otherwise, people who are waiting to show autonomous mode are there. Okay.
Journalist, you told you will give some command. You will give the command. Where do you give? How do you give the command?
Sir?
You told you will give some command in between.
Using laptop.
Laptop in there.
Yeah.
Okay.
We have connected Jetson by using SSH in laptop.
SSH to that?
Yeah.
Okay, okay, okay. something if it tells we can. Journalist, is it identifying safe spot or is it identifying what is the feedback?
We are facing some issues in Wi-Fi connections. So the display is tracking.
Okay.
We can't see the GUI.
Okay, journalist, give what is the feedback?
1 minute. பேட்டரி சார் இங்கேருந்து லேண்ட் பண்ணி இப்படி வந்த நீங்கள் அப்படி சுற்றி இப்படி வந்து இங்கே லேண்ட் பண்ணுறதுக்கு எது கட்ட இது வரலாம் பரவாயில்ல நம்ம அட்லீஸ்ட் சேஃப் ஸ்பாட்டில் லேண்ட் பண்ணிடலாம் சார் இது கட் ஆகுதா
இப்போ வந்துச்சு லேண்ட் ஆன அடுத்த செகண்ட் கனெக்ட் ஆயிடுச்சு
கனெக்ட் ஆயிடுச்சா சரி நீங்கள் லேண்ட் பண்ணிடுங்க ஒரு வாட்டி அவங்க அதான் கேட்குறாங்க
Stream is over.
Participant team, you are requested to come here for question and answers.
Yes, sir.
Journalist, anything? You could get the
Sir, actually, we have planned to scan manually and start to identify the safe spot. But what the problem is, after scanning and moving to somewhere, our display got corrupted and
the data is stored now? Data is available?
Sir? Yes. But the display was struck and it was not.
Okay. You will be able to process anything now, right now?
1 minute.
Okay, anyway, go ahead. It's a good attempt. Okay, don't worry, it's a good work. Okay.
Yes. Thank you.
How much time do you have?
Start setting it up.
Sir, can we show our idea 2 minutes?
Yeah, you tell what you want. Yeah. What you have.
So actually, this is our camera, that camera Z2A, which scans the arena. So this is, as I said in the morning, this was the arena of 12 meter cross 9 meter, and it was divided into 432 grid cells. Each grid cells is 50 centimeter cross 50 centimeter. So here full red is there. So this means it is in hazardous zone. And here green color is available, right? So that means flat zone. So here the group of green flat zones are colored by blue color. So that is identified as safe spot. After identifying that safe spot, here VO is displaying. The Jetson will capture the VO and it will send to the PIXOC in NED format, north east down format. And after receiving the coordinates by PIXOC, it will land to home.
Okay, this data where you generated?
Yes, sir. So it is live. So
now, okay, whatever you are showing. Okay,
yes,
right, understood. Okay. Then you can show something where it is some other different. You just show just for understanding. Camera you just show here. What it shows.
Like no flat zones.
Okay, if it is flat, will it show green? That will show there?
Afterwards, then let them set it up.
Okay, it has to.
Where is the camera?
Some thresholds may do. Okay, image, what
Like-
image it is looking is slightly. You show close. Okay, it got stuck, I think.
Huh.
Yeah, okay. Okay, good, very good, nice.
Thank you, sir. Thank you, sir.
Next is Team Anveshak from IIT Madras. Anveshak from IIT Madras.
So, IIT Madras and Anveshaka, you are ready? You had some issue in identification of border, and you told you will go only with the safe spot. Okay. Okay, no issue. And only one chance. Correct? No? 10 minutes or whatever.
Yes.
10 minutes. Go ahead. Yeah. Go ahead with. Srinivas starting? Yeah.
All switches up. Okay, we are ready to run the code. Run. We have run the code. Takeoff.
Srinivas, you just tell you are going to do.
Okay, the drone has started scanning the arena.
Oh, again, scanning means?
No, this is fully autonomous.
Okay. No, next it has died. No, he's just scanning only, I think. Srinivas, can you? Srinivas? Oh. Is it
Yes.
first identifying the safe spots and trying to
Yes,
land?
right now what's happening is we have hard-coded a particular path that we wanted to do. It's going to scan the entire arena, and now it's heading back to the safe position right now, home position right now. So it will land, and our safe spot detection code, our safe spot detection code is now going to identify the number of safe spots that we can actually safely land in over here. He'll explain more about it.
Okay, this autonomously landed back to home position now?
Yeah, it autonomously landed back to home
okay,
position.
good, that's
and is scanning the map now.
Now it is scanning the map.
Okay,
And
we have
identifying-
detected safe spots. The drone will take off again now.
Okay.
Okay, drone will take off now. Drone is moving to safe spot 1. Slightly off, but still within the arena. The drone will take off again.
Is it fine?
Drone will take off again.
Okay, how many safe spots it identified?
It identified 5 safe spots. Some might
Okay.
have been repeated.
Okay, good. Okay, fine.
Kuruti, keep it down, keep it down, keep it down, keep it down.
Okay, will it go for other two again? No, you can explain now. Further, is it going to go for other 3? You identified. Okay.
Yes, sir.
It's waiting, is it?
Yes, sir. Yes, sir.
Okay. Yeah. Yeah. It identified 5. Did it identify these places? You could see that?
Sorry, sir?
The required safe spots, did it identify?
Yes, sir.
It has identified.
Yes, sir. It identified the safe spots. We didn't. I didn't see the coordinates.
Okay.
Like,
Oh, safe. Okay. This is also another safe. Okay, good. Next.
sorry, sir. So we are calculating the slope across a grid. So we actually yes, sir. But the radius we gave it is like 1.5 cross 1.5 cross meter. So
But it didn't identify the boulders, I think, clearly.
yeah. Actually, we are passing a kernel like in the map, and then in the every kernel we are used to detect the slope from the center point to the corner points. So like it's a 3 cross 3 kernel. So by averaging the slope, like we will get slope for every point in the arena.
Okay, landing and this is okay, good. I think the thresholds are some different, isn't it? I think. Okay, I think. Okay, good.
Okay, so one issue we found in the safe spots was that it started identifying the gaps between boulders as safe spots to land.
Nice attempt and okay, it identified 4
should have worked, and wherever we stop the corner, so that will be given as the offset. Like from that point, we will create a map. But now, like we have given the corner manually, so the map will also be like it's not completely connected with like what the drone is giving to it. So since the offset which we gave manually was slightly off, like it got shifted towards right, sir.
Your map detection is having that offset.
Yes, sir, the offset and the corner, which should be given by the corner detection code. But since our corner detection code and line detection code did not work properly, we gave it manually. I mean, manually in the sense what we hard coded it and we gave it through the code in the code. So yeah.
Once you detect that,
yes, sir,
you will update the coordinates.
Yes, sir.
Why it is not gone to that update should be from the sensor only. Offset should not happen, no?
Sir, what offset you're talking about? I mean, like the
map when you are building the map.
Yes, sir.
That map itself is offset, or that location of that point is an offset?
No, sir. The map is offset.
So we don't want any points coming outside the arena.
So we will be checking the ratio of the box, yellow box which is being formed. If it aspect ratio, so if it fits in the ratio of like a rectangular region, so then we will be detecting a line, and we'll also have a depth. The Z2i gives a depth map, so that will be giving the distance of the yellow line, and based upon that we will be moving towards a line. That was a pre-planned one. Yeah, yes, sir. Right now we are not doing any line detection. We didn't do any line detection nor the corner detection because our corner. Yes, sir. It did. Yes, sir. We initially in the earlier code it detected the line. I mean, so what we did, we were looking for a line initially. When it takes off, it will look for an yellow line which will be fitting in a specific which fits in the yellow HSV range, and that will be coming in the and we also gave a like a ratio, like what do you call the rectangular bounding box. Also we gave a ratio for it. So the what do you call range of ratios. So what happens is that if the range of ratios fits and if the range of ratio fits and the yellow line is also good, I mean every condition being satisfied, then yellow line will be detected. And we also find the distance of the yellow line. Based upon the distance, we'll move forward until the distance it reaches certain threshold, and then we will move towards left. Yeah.
No, now. But one thing I'll appreciate, your each landing was safe actually. Between the boulders, that definitely we can appreciate.
Yes, sir. Like we tested this code, like the boulder, the safe spot detection code is very heavily tested by us in our arena out there. So we are very confident that it'll always take off no matter where the drone lands.
Just one question. See, you have landed very nicely between the boulder. Is it just luck, or can you show us that it happens precisely?
So we have the map if you want to see the map.
So can you just show us in the map that it detected this and the navigation has landed?
Yes, sir. We have the logs saved. We'll go through them.
So at least precision of your landing gets demonstrated.
Yes, sir. Can you just give us 5 minute logs and go through them? Yes, sir.
Actually, the precision of odometry can be seen through the landing on the home position. Like you can see, it scanned the entire arena, scanned the entire arena, and then went through the 3 safe spots, and again went to the home perfectly. So this is the perfection of our odometry that we built. So yeah, so as map is perfect, the safe spot detection is working properly, and then like it's not a luck, and then it's our code, like which made.
That's just you don't take it so.
No, yes.
See, that's what. See, when you try to detect a color, you should always do a hue correction because your lighting condition changes. Yellow becomes white. Sometime then again it becomes a yellow. So just ensure that you do that.
Yes, it will happen next time. Although we did do it by the end of the second test, right?
See, any color pattern detection, hue correction is a must.
Yes,
you will
we
not
understand.
get natural light anywhere.
Right. And the other thing with the corner is the thing is, long story short, the corners are actually like the boundary was actually a bit too thick for us to properly run the corner detection code in. Yeah. So thing is, I'll explain the exact algorithm that we use over here. What we do is, when we get close to a corner, as if you're sufficiently far away from it, yes, we can understand that the Z is facing forward, right? So it will be sufficiently far away from it in 2 directions, so that we're actually able to see the corner in the screen. So what we do after that is, we have a bounding box around that corner. Now, what our condition is, if the center of the bounding box, the HSV value of that pixel is not yellow, then we know that it's a corner, and it makes sense. But if they're extremely thick, then the center can end up inside the actual yellow boundary itself. So that is the problem over here. We have fixed it, and with your permission, we'd like to test it. What we have done is we have moved it by a small offset to the side and down, so it will have a higher chance of detecting the mud instead of the yellow boundary.
And sir, as you said, we also did a hue correction after returning. Like, yes, sir. It was very helpful, and then now we can detect the corners actually. So if we get another chance, really we can detect the corner. Yes, sir. Yes, sir.
I really appreciate this. Thank you very much for giving a second chance to us. Yeah.
Yeah, just show
We'll
us
be
the
opening a map right
accuracy
now.
of
Yeah.
your
Okay,
odometer.
thank you, Anveshak team. Excellent, good performance.
Thank you, sir.
So next team, JART team, what you are going to do, you can explain, and then quickly go to the.
We are pulling up the map. Sure, we'll come to your place.
All right. Hello. Hello. So. Yes, sir. Okay, move and start.
He had some. He had a problem in identifying boundary. So he told he will do a manual one. That's all.
Two of us. People come. Both of you. Come. Maybe come. And if to do is there is a safety threshold that we have to cross for the things to detect. So this is very sparse. So we thought that once we reduce the safety threshold, it should be able to detect the safe spots.
That you are going to first try with a manual attempt.
Yes, sir. We'll try to do that with the manual
So you do
attempt.
that immediately,
Yes, sir.
manual attempt, and tell the result. And
Okay.
after that, 10 minutes time.
Okay, sir. All right. All right.
This also you do it fast.
Yes, sir. Yes, sir.
Manual also you do it fast.
Yes, sir.
Okay, okay, Saurav, you tell the results. Yeah. What was the results it could identify with this in this? It could identify this as a safe spot, is it? Okay, okay, good, good. Then proceed.
We'll just change the parameters and it will be done.
Which parameter you would like to do autonomous?
It's just a threshold parameter, sir. Just a number change in the code and it will be done. Sir.
Okay, okay, you will go autonomous now, isn't it?
Yeah, yes,
okay.
Sir. Yes, sir.
Only one attempt, go ahead quickly.
Yes, sir.
That's it. Correct. No, Saurav, already with the new threshold only you have identified, no? You should go ahead with that only, isn't it?
Yes,
Still
sir.
modifying something.
Yes, sir.
No, you told you have experimented with the new threshold in manual mode. Same thing should go for auto, isn't it? That's what you
Yes,
want.
sir, exactly. The model is same. We're just trying to see what the model can see with the reduced security threshold.
This experiment you have done.
Yes, sir.
With that new threshold what you have put, it is able to find out the safe landing place.
It should.
Now no change is required to be done in your system to do this autonomous, is it not?
The new security threshold, we have just kept it such that it can give all of the thresholds that it can find for a particular safe spot. So we have identified the number for
No,
it.
that means now it has detected more number of spots than these three?
It technically has, yes.
Okay.
Yes, we have to
You
slightly
have
tune
tune it once and then, okay, then only quickly do it so that
Yes, sir.
still one attempt you.
All right, sir. Yes, it's a lower threshold now.
Keep explaining what's happening. Okay?
autosave हो गया. Okay. छोड़ दो. Clear. Okay, so we have successfully changed the parameter. We'll be starting the autonomous flight shortly.
So right now the sensors are a depth camera and a LiDAR. The LiDAR is initializing right now. The LiDAR has the special ability to, yeah, please.
Saurabh?
Yes, sir.
Can we start with a different heading angle?
Yeah. One second. Yes, sir. Which heading, sir? Towards north?
No, which direction it is there? Now.
We can do anything, sir.
Okay, go ahead with the south.
This?
Okay, done.
All right. Right. Yeah. So right now, once we press enter, what happens is it tries to get the XYZ from the gyro and the IMU. And since, yeah, so the LiDAR is being initialized right now. The LiDAR has a special ability to take depth images of a very high millimeter precision, and it gives a 3D projection of a ground below. So that is how we determine the slope angle. So whenever we encounter a slope, we cannot normally disarm the motors. It will just keep on wobbling and it will eventually fail. So what we have decided is we use the rangefinder's data, and once the rangefinder's data is found, we, it will do whatever it does. Yeah. Please show the screens to them. Right now it is trying to find the yellow border. So it will try to rotate towards something that can determine if it's looking at a yellow border. It's a security feature that we have put. Right now it is trying to center towards the slant safe spot which we have seen earlier. So it will try to perform and go towards that. As you can see, it is trying to give a forward velocity while centering towards it. Now once that is done, it will try to go towards the home safe spot. Yeah. Now it will try to do some kind of ground analysis.
So it is able to identify now every time all the spots without the boulder issue. Okay.
So as you can see, almost while it was almost touching the ground, it shuts its motor down autonomously.
Okay,
this is
good.
due to the LiDAR working. It determines the angle of the slope, and so it actually determines on the spot whether it is a safe landing spot or a slant safe landing spot.
Okay, good. Now does it?
Now it will try to take off again. A few more seconds. It is trying to get the coordinate of this home spot, which we can see through the ground station as well, live. Now it will try to arm. Now it is trying to rotate and search for some kind of safe spot. This beep indicates that the rotor is in guided mode, which is controlled through the artificial intelligence that we have built as of now. I have taken the control out of it. One second.
Is it changed to manual control? No.
Yes, sir.
What did you say?
I slightly took the control of it because it was going to the sides.
Okay, you did control manually at this point?
Just for the rotation as of now.
Okay, okay.
Yes, sir. So it detected this spot, this rock, it slided to the front, sir. Images. It doesn't?
Okay.
Display. Okay. Okay, the system has frozen a little, that's all, sir. This is a network issue. We are using a mobile hotspot.
Sarva, the second detection was a slightly wrong detection, you are telling?
This is semi-autonomous.
Semi-autonomous. Okay, fine. Yeah,
yeah. Can you show the GCS to the professors? Yes, sir. Judges, please.
So we have detected the next safe spot, and we are.
So now you see that that is the safe spot that we are looking at. Since we have changed the threshold value to something lesser, the drone has identified that as
It is still trying to center to the safe spot exactly. Now it will try to go there and exactly try to land.
what we trained was a completely rocky test because we had to make the arena ourselves. So we went for a much harsher environment. We took a lot of rocks, hard rocks, and we had made the health checks and safety checks a lot precise. And now it's again detecting the slope.
Now it is trying to analyze through the LiDAR of about the ground below it. So if it gives us a flat safe spot, it will not disarm the motors prematurely. So since all the coordinates of the home spots and the safe spots are stored in the system, it can do a simple 8 and 2 type of function to go towards the heading such that it rotates exactly towards the home position so that it doesn't lose time trying to find something else. Now, while in the air, it will try to calculate the angle it has to rotate to face the home position. It has switched to guide mode, which technically enables it to rotate towards a particular home position. Now, as you can see, it has autonomously decided on how much to rotate to. It exactly sees the home position now. It will try to go there, exactly there. It always tries to center to the home position's coordinates such that it never misses. There is a low battery now. It will try to land on its own in the dedicated home position.
Oh, very good. Fine.
Sir, if we could
autonomously it had landed.
Yes, sir.
Okay,
It
good.
autonomously did that.
Good.
But if it would have been given more time, it would have actually gone there and landed there.
Okay, good, good, good,
Yes.
nice, nice. Okay, okay. But it will quickly go there, isn't it? Because so you told initially it doesn't have to.
Sir, there comes a drift, right, sir? In these type of IMUs and gyros, there is a lot of drift that happens. So instead of solely relying on the XYZ positions, which can go wrong anytime. In fact, on the Mars, we won't even have a normal magnetic field to even correct anything. So these all small things matter because of the drift keeps on adding. So what we had decided was we would continuously give a feedback loop such that it is a controlled PID system, such that it will go there, turn towards it at least, and see a particular safe spot that it can go towards. Yes, sir. Yes, sir. Distance is known, sir. Exactly, sir. Exactly. But sometimes it might overshoot or undershoot.
Or that you are trying to calculate your initial.
GCS, excuse me, sir. We would like to show our GCS, which is a proper control system. A few minutes, sir, please. This has the data is already there with us. Every single data parameter, velocity. Sir, as you can see here. Yes, sir. Sir, as you can see here, these are the continuous this rangefinder data. This is the altitude it gets.
So right now we just powered off the drone. That is why we lost connectivity to the Jetson. So if you could have seen the live stream over there, all the safe spots are shown over here. So all the parameters are here, and each and every event, like the entire sequence and control flow, is displayed over here. The Z versus time chart, which is the most essential parameter graph, is shown here.
Yes, sir. All this 3-meter altitude is already set, right, sir? So there is a 100 100 hertz frequency for the rangefinder that it continuously calculates the altitude.
Yeah, so now what we do is the whole thing is also streamed, and after the whole thing is done, all the information is stored in a JSON file. So I have made an analyzer for the same thing.
Yes, sir.
So over here, we upload the JSON telemetry data, we upload the events, and upload the safe spots, and they are displayed here. Now I'll do so. So
Yes, sir. Yeah. Please show to the judges. Yeah.
yes. So this
Team Titans.
Rotate the screen towards them. Towards ma'am.
Single screen with everything.
This is the GCS, right? So I've uploaded the safe spots TXT, events TXT, and JSON telemetry. So this all data is recorded as the flight happens. We can see it live as well. The stream is also live, right? So it stores each and every event in a file. We upload the file post-flight for post-flight analysis. So there is a playback option with the speed as well. So you can see I can change it to 2x, 3x, 4x, 5x, and you will be able to see all the movements.
We can see each and every parameter being changed here, as you can see.
So if anybody wants a closer look, I can come. But
yes, sir. All right. Thank you, sir. Thank you. Thank you, sir.
Excuse me, sir, can we start?
The Titans team, can you explain what you're going to do? Yeah.
So while they are taking the manual test and testing the system, so what happened that while the drone, when we started for the first run, the ESC or the electronic speed controller for the motors, actually it started misbehaving. It tried to fly in the first run. Also landing was little bit off, but was not according to our requirement because we planned to center landing. So when it again, it kind of hit here at the rock, the ESC actually got bad. So that's why it was toppling off when it was taking the flight. So we just replaced the electronic speed controller and now it's tested and now we will be.
Okay, now what you are going to show, you tell that us.
Yes.
What are you going to show?
So the safe spot point, the home point would be the same which was earlier, but this time the heading would be towards this side.
Okay.
So first we will start, go for the slope landing. Then
so autonomously will do?
Yes, sir, completely autonomously, autonomous takeoff, going forward, scanning for the safe spot, and once scanned, detected, center aligning, landing, and repeat for 3 times. Then once completed 3 safe spots, it will go for the home.
Okay, you have one attempt to do. Just take 10 minutes and complete.
Sure, sir.
We will
Thank
not
you.
take more time. Okay.
Thank you.
That's all. Please go ahead quickly.
Yes.
Sanjit, you are, okay, you only for safety you hold this. No, no. Oh, you're, no, no, for him, no, that whatever the RC thing, no? Remote control, what?
So we will take again a manual flight to check it.
Okay, good.
We will
Do
tell
it
you
and
when
keep
the
it.
autonomous will start, and then it will be completely autonomous. घे तुम्ही थांबले कशाला? थांबले का बरं होते? मी म्हटलं इंडिपेंडेंटली घेऊन घ्या. Now we will taking a little small manual flight just to check everything is running and going up. It's completely manual. You will take off little bit of roll and pitch, then you will land it off.
Okay.
Are we okay? ये PPT बंद कर. We are ready. Team ready? Tavish? Ready? Padmesh? Ready? Nanesh? Ready? Okay. Now we will be going for autonomous.
Okay,
the complete
good. All the
further
best.
flight would be autonomous.
Good.
Thank you.
The autonomous task has finally initiated, slowly increasing its altitude up to 3 meters of height. Moving camera from upside down to maintain the odometry. Now ANAV is in the navigation mode, which is a spiral-based navigation. Moving forward in search of safe spot. Our ANAV has detected a slope landing spot. As you can see in the HOD, it also detects the direction of a slope and the tips also.
We have taken a manual intervention.
Yeah.
Yes.
Okay. You tried to correct manually? Okay.
Yes, sir. It was going beyond the control, so that's why. Now it is autonomous.
detected a second safe spot, trying to align itself with the center of a safe spot. Slowly decreasing its altitude for a safe landing. Saving the coordinates. Taking off again. It's going to search for second spot again.
We have taken the manual intervention. It was going outside the yellow border. Now again, autonomous has started.
detected a first landing spot, slowly
And it has successfully landed on second spot.
No, again it went to the same point, isn't it?
So first he missed, like it
Okay. Then next
came
what?
front, it landed there, and then now again scanned in the spiral search pattern, and then he.
Okay, this was done autonomously?
Yes, sir, completely autonomous.
Okay, good. Then next what now?
I guess there was a question regarding the slope detection.
Sanjay?
Yes, sir.
Yeah, what happened? Over. So over? Is it over?
Sir, actually it is very close to the boulder.
Sorry?
So we have to just shift it little bit there and it can
Okay.
again continue. We can
Okay,
have
go ahead quickly. Yeah.
Hey,
Then what you will
थोड़ा सा
demonstrate
shift
after
कर. थोड़ा सा shift कर तला तिकडे.
that? No, what you will demonstrate? Further?
Yes, sir. Again.
Further what? 10 minutes over already. Okay.
The next home port में क्या? Next home लेने गया. Sir. Next home. Now it will be going back to the home position. Yes, sir.
You see manually intervening, we just want to confirm. Okay.
Yes, sir. It has just moved the position. Yes.
Let you inform him not to.
Yes, sir. Tavish, okay, autonomous? Okay.
You leave it autonomous, don't hold it. Sanjeev?
Yes, sir.
Come. It should have gone back to its original coordinates, no? Why it is again searching?
Sir, the thing is happening that there is a FLVIS coordinate-based system which is tracking the data. So when it start first takeoff, it was 0, 0. It taken off, it has scanned, land, it's completely saving the data, it's maintaining the coordinate system. So because the thing is that red light is there, it's not aligned, like came to a position or a specific height for the navigation. It's struggling with the altitude. No, sir, it will take a specific height which is 3 meters and then it will go for the 0, 0. Sir, that. Sir, the thing is that it is actually a rangefinder based altitude measurement. In the rangefinder, it directly launches the laser to the ground and measures the data. Yes, sir. When he was scanning, he thought that there is a safe spot and he tried to land there. But when he came closer, sensors got his data that it is not.
No, Sanjay, why it is searching what it is doing? It's supposed to go to home.
It's have been little bit stuck on a subroutine.
Okay.
So can we have the manual?
Manual and it will close. Okay, good.
Take it manually to the home. So it's actually facing downwards. Yes, sir. So, so actually it might stuck in a subroutine where it has to achieve a height, but it is not getting the proper sensor data.
Okay, good.
Thank you, sir. Thank you so much.
Attempt and everything is done. 2 times nicely detected. Very
Sure,
good.
sir.
Excellent.
So any questions or anything regarding? Yes.
Yeah, good.
Okay.
Good done.
Thank you, sir. Thank you so much. Thank you for every jury to giving us
Well done, all.
a second chance. चला, निघा, back up.
Tomorrow is much more hectic than today. At least today we have some leverage. Tomorrow you don't have. Huh?
How we will be able to finish? 7 o'clock you put. Now we cannot change that. 7:30, 7 to 7:30 tiffin you put.
Okay, you can. The next team will come. Please go ahead.
But you are 8 to 9 you have to finish one. If you are not finishing, it's problem.
5 hours we will plan. 6 at least 5 will be there. Afternoon 1:30 to 3:30. 45 minutes.
Given all together. You take this.
Telemetry is on. Someone else's telemetry is on. We can't connect to our telemetry.
Other teams, kindly switch off your telemetry. If anyone is in this hall, kindly switch off your telemetry. Team Titans, have you switched off your telemetry?
Yes, sir, we are trying again.
Any one of you are...
Trailblazer team? What you are going to plan to demo? Anyway, you have selected this point, that's fine. So, what are you planning to do? Can you explain?
Sir, first we are going to map the whole arena.
By autonomously you are going to do, or?
Yes, autonomously.
So, you know the requirements, no? Did we discuss that?
Yes, sir.
So, you have to start from home spot and scan all the safe spots.
Yes, sir.
And that is all the three safe spots. In any order, you have to land and take off and go there. And you should identify the border areas, border by the yellow lines, okay? So they didn't start, sir, actually. They could not start. If I remember, the programming was going on still, correct? That's what is happening.
Sir, programming is not going on. Our system got corrupted at the end moment. That's why we have to rebuild it from the scratch.
Okay. Okay, then you downloaded it to that, is it? What
No,
was
sir,
the issue?
actually, we are using Docker. Docker, and actually what happens when we are plugging out, so there is a electricity shutdown suddenly. That's why images not get.
Now is it okay? Now?
Now it's okay. Fine.
Okay.
Yes, it's connected now. All good? Now, sir, we are ready to fly. Yes, sir, autonomous.
So the team, you can say manually, okay, take control. Now, Akshit, no? Akshit,
Yes, sir.
what you are planning to do now?
Sir, actually, we are just rebooting system.
No, what happened? Manually you were trying to do scan or what? What was happening?
No, sir, it's totally autonomous.
Autonomous. It did detect the border?
Sir, actually,
What was the issue? Could identify?
so actually, what happened? There is a random yaw dot get in the drone area.
Okay.
So that's why the axis of the drone got tilted a little bit.
Okay.
So there is some calibration.
So was it trying to scan first, not identifying safe
Sir.
spot, or what was the plan?
Actually, sir, it's trying to scan, but we are set some thresholds that
Okay.
if there is a ball, like there are some other colors, like there is some object in yellow color in the arena, for example. So it should don't detect.
Okay.
There is a threshold kind of thing we implemented. So what happened is that there is a threshold not crossed. So that's why it's just keep on going.
Okay, now you are trying to reboot and
थ्रेशोल्ड चेंज किया क्या? Yes. We changed it. What's that? Lights का lights all fine.
went off, power went off or something, battery or something went off, disconnected.
Sir, due to this crash, our SSD got broken.
Oh, is it? Okay, okay, bad luck, okay. why it fell down? The power or anything? Got
Actually, sir,
disconnected?
in gesture node there is a SSD attached in the.
Right, that's
and
fine. Why it fell down first?
निकली कि टूटी है? Sir, it just actually fall out, not broken. It just fell out.
The screw got broken.
Screw got broken. Sir, actually the impact that last second one. So when it's
Why it fell down is that? Did you find the reason? Oh, but then
I think probably the reason for that is
previous incident. Oh, okay.
What got disconnected?
Okay.
Screw. The screw is also broken.
Like the screw breaks, why it should fall down?
So only some battery or power gets disconnected only it can.
Screw has broken, what has happened?
As long as your this is running, nothing should happen.
When the autonomous thing was running on this, as the SSD got disconnected, the whole Jetson got shut down. And it
got disconnected.
Yes, sir, SSD got disconnected in between and it broke. No, sir, it disconnected before that.
actually between the flight it got disconnected and then
Control got disconnected.
vehicle just got down.
Okay.
So actually, there were two problems with the legs. It was increasing the height, so toppling was very easy for me.
In inclined plane there is a toppling issue.
It fell down.
Yes, sir. Yes, sir. It will touch it, but if we are when we are using legs, so when we are trying to land in inclined plane, so the leg got slipped, not able to hold to the surface. But with this arrangement, it's able to hold to the surface very easily.
It is disconnected, but electrically it's not connected now, is it?
Yes, sir. SSD got fall out. That's right. Actually, you can see it here. There is a screw that.
Okay.
That part just got out between the flight. That's the issue.
Okay.
The SSD dot.
Okay, man. Okay, fine. So good attempt anyway.
Screw got broken.
Very good attempt. Nice. Okay, all the best. Takeoff was very good, very swift it went and very nice.
Sir, main reason was
Sorry, sir. Sir, we have actually another proposal. We can still showcase the emergency because it is not dependent on this. It is not dependent on autonomous. We can still showcase the emergency. No, we can do it right. We can do it right. 3 o'clock.
understand that